So the first part of 3.5 that I want to be clear about, so this is chapter 3.5. I'm going to draw a segment, but I'm going to use a little different words. I'm going to say this is a directed segment. What that means is it's kind of like a ray. We're going from A to B. Okay, so it's a directed segment. And what I want to do is I want to divide this up. I want to place a point P along the segment here somewhere. Along this segment in a place so that it's the ratio that we divide this segment up, let's say is that AP over AB is in this ratio, 2 to 1. Okay? You guys understand ratios? Let's see how much you understand ratios. That if I want to put point P in a spot along here so that the ratio from A to P and from P to B is 2 to 1, how many equal pieces do I need to divide this segment into? You don't understand ratios. Okay? Think of it this way. AP is going to take up 2 parts of the segment to, PB. To PB's 1 part. So I've got to divide this segment into 3 equal parts. Now I could do that by construction or all kinds of stuff, but I'm just going to show you. Okay, let's divide this segment up into 3 equal parts. Okay, if I put point P right there, then AP is 2/3 of the segment, and PB is 1/3 of the segment, or P is 2/3 of the way along, right? Does this make sense? Okay. Okay. Now that's all fine when we have a segment like this. When we have it on a coordinate plane, I'm going to do this kind of an easy way. I'm going to cheat a little bit. But I have this directed segment AB again. Let's say we'll put B right there. So what do I mean by directed segment? Means I'm starting at A and I'm going to B. Kind of like a ray, only I'm not going through B forever. I'm stopping at B. Okay, but it means we have a definitely starting point in a direction. Okay, so this time I got to count. Okay, this time I want the ratio of AP to PB. I want it to be 3 to 1. So I want to place point B along the directed segment AB so that the ratio of AP to PB is 3 to 1. Okay. Now, how many equal parts do I need to divide my segment into? Okay, you guys now understand this a little better, don't you? I need to divide it into 4 equal parts, and then I want to go 3 of those along, right, and put point P, and then 1 more would be, okay, and we can do that, because I cheated when I drew this. Did you see me counting?
Yeah.
So I was going, did you see how I was going up 1, or up 3 over 2? Up 3 over 2, up 3 over 2, up 3 over 2. So I already had it kind of divided up into 4 parts in my head, didn't I? Okay, and I know that if I put point P right here, okay, that's going to be 3-to-1 ratio. See the 3-to-1 ratio? Pretty slick, right? Okay. Now, what if point P was not located in a position where the x and y coordinates were integers? What if it was 4.5, 2.7, right? Can you see how that would make life a little more difficult here? Okay. Or if I just told you to do this segment and I said I wanted it into 5-to-1. Well, that would make life more difficult, wouldn't it? Okay. And so we need to be able to do it without having a canned problem that we can just divide easily into 4 parts and take 3 of them. So we're going to talk about how we do that. Okay. So first of all, let's look at point A right here. We need to know what the actual point is. It's -5, -4. Remember, this is a directed segment. So we're going from A along to B. Got it? Okay. Now, that -5 is going to change some. Okay, it's going to have some change to it. We're going to add some amount to that -5. And if you think about this, from A to B, can you see the horizontal change here? See how we have a horizontal change? How much horizontal change do we have? Can you guys see it? From -5 to 3. How much horizontal change is there? 8. And then let's talk about the vertical change. The total vertical change from -4 to 8 is 12. And they're both positive changes, aren't they? Right? They're both positive changes. Okay. So, what I want to do is I want to do some change to this, and I want to think, how far over did we end up going here to get to there? We went over what? 6 out of 8. Okay, 6/8. Reduce that down for me. 3/4. We went 3/4 of the way over to B, didn't we? Okay, so we went 3/4 of that amount. Well, where else can we get 3/4 from? Okay, we want to go 3 along the way out of how many separate sections? Remember how we said we're going to divide it into 4 equal sections? Well, we're going to go 3 of those 4 over. So what we're going to do is we're going to take 3/4 of the horizontal distance, and we're going to add that to the 5. To the -5. What's 3/4 of 8? 6. -5 plus 6. 1. We're going to go over to 1. Okay? So point P is going to be 1 something. Now to the -4, to the y coordinate, we're going to add some to it. Okay? And we're not going to go 3/4 over this time. We're going to go 3/4 what? Up to B. So we're going to go 3/4 of, okay, now what is the vertical change here? 12. Okay, you guys know what 3/4 of 12 is? Is it 8 or is it 9? Divide 12 into 4 equal parts. Take 3 of them. Times 3. Isn't that 3, 3, and 3? So we're going to add 9 to this, which would give us what? 5. 1, 5. There's our point. Are you all thoroughly confused? Little bit. Okay. Now, we're going to do another one. Here's point A, 1, 3. Here's point B, 8, 4. We'll make it 8, 4. Okay. I want to place point P between them so that the line segment AB, so that AP over PB is in this ratio. So I want AP over PB, I want it to be in the ratio of 4 to 1. Okay, so first thing, I'm going to take this segment, I'm going to divide it up into how many equal parts? 5. And of those 5, how many am I going to go along before I actually place point P? 4. Okay? So, I want to divide it up. I want to divide it up into 5 equal parts, and I want to take 4 of them, okay, and add that amount, that much to this one right here. Okay? But here's the thing. Of how much? Of the horizontal distance, right? Okay? So I've got this point here, I've got this point here, here's A, here's B. I know that this point is 1, 3, and this one is 8, 4. What is the horizontal distance from A to B? How far? 7. And what is the vertical distance? Oh, it's only 1, isn't it? Okay, so this one's actually only like right here, isn't it? Okay, so it's only 1. And isn't that kind of the slope, guys? It's not reduced, but if you look at the slope, but you need to know what is, from this point to this point, what is the horizontal distance? Because I want to take 4/5 of that. See, I want to divide this into 5 parts. 1, 2, 3, 4, 5. I want to take 4 of them. I want to go over that far. So I want to take 4/5 of that 7, and I want to add it to the 1. And I want to take 4/5 of the 1 and add it to the y coordinate. You got a calculator? We can use a calculator for this, can't you? Do it. You can even use one of mine. Remember, we want to add 4/5 of 7 to 1. Think about what we're doing here. We're dividing 7 up into 5 equal parts, and we're taking 4 of them. And we're going to add that much to the 1. 4/5 times 7 added to the 1. I got 6 3/5. Is that what you guys are getting? Everyone got a fraction button on the calculator? Isn't that nice? Okay. And then can we do it to 3? I'm going to take that 3 and I'm going to add 4/5 of 1. Wait a minute. Let's not do that on a calculator. That hurts my heart when you do that on a calculator. What's 4/5 times 1? Thank you. What is 4/5 plus 3? Oh, it's 3 4/5. You didn't want a calculator for that, did you? No. Okay, so let's just think about this for a minute. If this is 1, 3, and this is, it would look more like this, and here would be the segment. 4/5 of the way along, right there. That's seeming. Do we want to put it on a graph so you believe that it worked? One 3, 8 4. There's our segment. 6 3/5. 6 3/5, and then 3 right there. So here's point A, here's point P, here's point B. What do you think? Is it in the ratio of, what was the ratio again? 4 to 1. So 1, 2, 3, 4 to 1. Yes? Are you less confused now? Still a little though? Third time's the charm, guys. Here we go. Okay, this time, point A, -2, 1. Point B, 4, 5. I want to place point P on here so that the ratio of AP to PB, I want it to be 3 to 7. So we're not even going to go halfway this time, are we? That makes sense? Not quite halfway to B? Okay. So think about this again. How many pieces do we need to divide this segment up into? 10. Okay. And how many of those 10 do we want to go along from A before we put P down? 3 of them. Okay, so that's what we're going to multiply in both cases. So we're going to take -2 plus 3/10 of the horizontal, the x, right? The change in x from here to here. What is the change in x from -2 to 4? What is that? 6. Okay. And then we're going to take the 1 and we're going to add, that doesn't look like an add symbol, does it? It looks like a time symbol. Add. We're going to add 3/10 of the vertical distance. What is the vertical distance from 1 to 5? 4. You have to be careful here. If the vertical distance is negative, you have to put a negative number here. Right? Okay, think about that. Now I think on all of them, in this book I think, A and B is always to the right and higher. But it doesn't have to be that way, does it? Okay. So can you guys do this? Get out your old calculators and see what you come up with. -2 plus 3/10 of 6. You guys realize on your calculator, if you put -2 plus 3/10 of 6, your calculator, it doesn't do freshman math. It multiplies first and then adds. Right? Is that important? You can't go -2 plus 3/10 first and then times, right? But your calculator knows that. So, are you less confused now? Okay. Now I'm going to give you one to do yourself. All by your lonesome.